Hello again, everyone. So for this video, we're on page 219 of the binder, our first video here of second semester, and we're talking about exponents. Okay, so exponents probably something you've heard before, and at the top we've got some key vocabulary here. Okay, so when you look at an exponent here, the exponent is actually that little raised number. So in this case, it's the 3. So we have 10 to the third is how you say this. And so that 3 we call the exponent. 10, the number that's being raised to the exponent, that's called the base. And then that whole thing together, and this is a word we're going to try to use a lot this little mini chapter here, is power. So the whole thing is called a power, and that's kind of a misconception. A lot of people think you can also just call 3 the power. In fact, I used to think that too, but 3 is actually just called the exponent, and the power is the whole thing. Okay, so that exponent is really trying to be, it's like shorthand for repeated multiplication, right? So what does it mean to square a number? That means raised to an exponent of 2. And then to cube a number is to raise an exponent of 3. Raised to an exponent of 3. Okay, so here's an example of a cubed number up there, the 10 to the third. So in example 1 here, it says expand the following powers and evaluate when possible. So if the math's not too crazy, we'll evaluate it. Okay, so 2 to the third really means 2 times 2 times 2. Oops, times 2, 3 times. 2 times 2 is 4, times 2 is 8. So 2 to the third is 8. 7 to the third, and I'm going to pull out a little cell phone calculator. You could do that too if you want. 7 to the third is 7 times 7 times 7. So I know 7 times 7 is 49. 49 times 7 is 343. Okay. Now look and see here, negative 3 to the third. Notice the negative 3 is in parentheses, so that is the number that is being multiplied by itself 3 times. So when I write this out, it's negative 3 times negative 3 times negative 3. Okay, so we got to think about that. It's a negative times a negative times a negative. Right? Well, that first negative times a negative makes positive 9 times negative 3. Okay, and then that positive 9 times negative 3 makes negative 27. Okay, so the negative to the third power is a negative number. In D, I get negative 2 times itself 4 times. Negative 2 times negative 2 times negative 2 times negative 2. Well, let's break this down into pieces here. So we've got the negative 2 times negative 2 is positive 4. This negative 2 is positive 4. We're still multiplying. This is all multiplication. So now I get 4 times 4, which is positive 16. So negative 2 to the fourth is positive 16. All right, so then let's move on here. I'm going to skip a few of these. Let's do F. 8 over 2 to the fifth. Okay, so in this one, we're going to do 8 divided by 2 times 2 times 2 times 2 times 2. One more. All right. And let's see, that's 2 times 2 is 4, times 2 is 8, 16, 32. Oops, so that's 8 over 32, which reduces to 1/4. So 8 over 2 to the fifth is 1/4. Now look at G, and let's compare it to D. There's a big difference, and it's important. These aren't the same problems, okay, or similar problems. They're very different because there's no parentheses, right? So when there's no parentheses, what this really means is it's actually saying negative 1 times 2 squared, right? And that's a big, important distinction because it's not saying negative 2 times negative 2. It's saying negative 1 times 2 squared. This is really an order of operations issue here, okay? So that's negative 1 times 2, which is negative 4. So the answer to G is negative 4, okay, because there's no parentheses there. Looking at H, similar idea. There's no parentheses, so I'm going to change it to negative 1 times 2 cubed, which is negative 1 times 2 times 2 times 2. That turns out to be negative 8. All right, so there's a big, like, it's really important when you see parentheses versus no parentheses. Okay. What's also important is the placement of the negative, because here in I try to trick you. All right, there's parentheses, but the negative's not part of it. So it's the same thing here. This is really -1 times 5 to the 4th, which is -1 times 5 times 5 times 5 times 5, which is -1 times, let's see, 25 times 25, which is -625. Okay. So a lot of times we'll try to kind of play with you here with the negatives and the parentheses. So J, you've got a negative outside, that just represents a -1, times, and now I'm raising -3 to the 3rd. So I get -3 times -3 times -3. So one of the things you'll notice is when you have an even number of negatives, they're going to cancel out, because negative times negative is positive, and negative times negative is positive, so it's going to all be positive. So we get, this one's 3 times 9, which is 27. In L, we can do K. K is 4 to the 3rd minus 4 squared. So this is 4 times 4 times 4 minus 4 times 4. That's 64. 16 times 4 is 64. Minus 16, which is 48. Okay. And finally here, L is 1 to the 100th, which is 1 times 1 times 1, 100 different times. 1 times 1 times 1. Skip a few times 1. We do that 100 times, the answer is still just going to be 1. Okay. All right. So some of this we're going to kind of skip around. We'll talk about the common exponent page in class. But if you turn to the next page, 220, we're going to do some of this right now in the video. Okay. So what I want you to do is take a moment and try to fill out as much as you can right now. All right, so pause the video and fill out as much as you can. Some of this you might not know. You could use a calculator or unpause the video and we'll get some of it filled in together as well. All right, so at the top of the page, I filled in the top kind of 2 sets of boxes here. So the 10 to the 3rd, 10 to the 2nd, 10 to the 1st, that's all like we just did on the front page, right? So you see how we get 1,000, 100, 10. And then for 2 to the 3rd is 8, and then 4, and then 2. Now, when you do a fraction to a power, it's still the same thing, 1/3 times 1/3 times 1/3, which is 1 over 27, and then 1 over 9, and then 1 over 3. Now, the middle set of boxes here, 0 exponents. What you notice here, these answers of 1, they come from the pattern here. So if we start with 10,000, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, 10 to the 0, we want to continue this pattern. Okay, so it starts with 1,000, then to get to 100, we're really dividing by 10. And then we divide by 10 again to get to 10. So as we take 1 away from the exponents, we're dividing by 10 each time. So to get to 10 to the 0, we should divide by 10 again. So 10 divided by 10 would be 1. And that same thing holds for all of these. So anything to the 0 power is 1. And actually that goes in the box here. Any number or variable raised to the 0 power is equal to 1. Okay, that's a nice rule to know. There's also this part, the negative exponents. Okay, and we just kind of want to preview this here. So if you take your calculator and you do 10 raised to the negative first, the calculator is going to tell you 0.1 or 1/10. And 0.1 as a decimal, 1/10 as a decimal is 1 over 10. Right? And then if the calculator, if you do 10 to the negative 2, you get 0.01, which is really 1 over 100, which is 1 over 10 squared. So if you're good at patterns here, you might think, okay, this is 0.001, that's 1/1000th. Okay, and so I'm trying to get you to see the connection here between 10 to the 3rd and 10 to the negative 3rd. The 10 to the negative 3rd really just puts the 1,000 on the bottom instead of on top. Okay, so we could do that same thing. I'll talk about those in class a little bit more. in this box here, we'll talk about some of those in class as well. I want to finish up at the bottom of page 220, and we'll go on to 221 for just a second. Okay, so these examples here, it says expand the following powers, showing repeated multiplication, and then simplify to a single term. Okay, so what we have here is, we call this a product of powers, because x to the third is a power, times x to the fifth. So it's a product of powers. So we want to see what that ends up equaling. So x to the third is x times x times x. But then I'm multiplying that by x to the fifth. X times x times x times x times x. Right? What's good to know here is this is all multiplication. So really, this is just a bigger repeated multiplication. Now there are 8 x's total, so I get x to the 8th. All right, that's simplifying it to, like, condensing it to a single term. All right, let's do another. X to the fourth times x squared is x times x times x times x times x times x. So 4 and 2, that gives me a total of 6 x's. Maybe you're seeing a little bit of a pattern here. X times x times x times x. There's 4 x's total there, so that's x to the fourth. All right, here we have x times x times x times x times x times x. I'm saying x a lot. How many there? 1, 2, 3, 4, 5, 6. X to the 6th. So what you might be noticing here is you can just add up the exponents. All right, x to the third times x to the fifth becomes x to the 8th, 3 plus 5. And if we turn to the next page, right, we have a place to put that rule. So we'll finish off the video here and with a couple examples. So when multiplying powers with the same base, I can add the exponents. That's the rule. Add the exponents. Okay, so we call this product of powers, and it's a to the add the exponents, so I'd write m plus n, and that's kind of the algebraic rule for it. So part A, we'll just do a few of these, or example A to the 40 times a to the 33. I just add those exponents up. I get a to the 73. In part B, 5 squared times 5 to the 7th would equal 5 to the 2 plus 7 is 9. We could get that answer on a calculator. We'll just leave it like that. F to the 14th times f to the 3rd times f to the 7th would be, that's 14 and 3 is 17, and 7 is 24. So f to the 24th power. Let's skip down a little bit just to do a couple more examples. Getting a little long in the video, so we're almost done here. Part G, let's try G. X to the 8th times x to the negative 4th. I'm still going to add those together, and I get x to the positive 4th. All right, even though it's a negative exponent, I do 8 plus negative 4, which is 4. H, x to the 5th times x to the negative 5th. Well, 5 plus negative 5 is x to the 0. But we had that rule from the page before. Anything to the 0 power is 1. So my answer there is 1. It simplifies to just 1. I is important. So here, again, what we can do is when we have like big numbers, not exponents, 3 times 2, I'm still going to multiply this. So 3c times 2c fourths, c to the 4th, times c to the 7th. Okay, it's all multiplication. So I get 3 times 2 is 6. I just multiply those big numbers. And then c, I just am going to add up the exponents. So this is 1, 4 is 5, plus 7 is 12. Right, that's c on the outside is really c to the 1st. All right, we can stop there. And thank you for watching.